In this video, I will be going over Lesson 21, Scale Drawings. Our first question says triangle DEF is a scale drawing of triangle ABC. So when we're determining scale factor, we are writing the number for our scale image over the original. Okay, so this is our original image here, and I'm going to choose this bottom side, which has a length of 9. So when I'm looking at my scale image, I want to also choose the same side, and that has a length of 3. So my scale image here is 3. My original image is 9. So that would mean I have a scale factor of 3 over 9, or 1 over 3. So 1/3 is our scale factor here. Our next one. So here we do have decimals, but that is okay. You want to make sure you're picking the same side. So if I pick the bottom on my original, I want to pick the bottom over here. Say I chose the top on my original, I would choose the top on my scale image. It doesn't matter which sides you choose, you will get the same answer for all 4 or all 3 or all 5, however many sides there are, because when we reduce it, we will always get the same number. So again, my original image is 5. My scaled image is 7.5. So I'm going to put my scale on top, 7.5 over 5. Again, type this into Desmos, and you will get that it reduces to 3 over 2. Okay. It is okay if you type it like this into your workbook. However, we want to get in the habit of always reducing our scale factors. All right, now we're going to do something a little bit backwards, and we're going to go from, we need to determine what this value of x is, okay? And to do that, we're going to use other side lengths that we know. So I'm going to pick this far left side here of my pentagon, and then I'm going to pick this same far left side of this pentagon. My original image is 5, and my new image is 2.5. So I'm going from a 5 to a 2.5. Okay, so I want to think, well, what math am I doing here to get from that 5 to 2.5? Okay, well, I know that 2.5 is half of 5, right? If I were to cut 5 in half, I get 2.5, which means that I am dividing here by 2. 5 divided by 2 gives me that 2.5. So when I look at the bottom here, 6 and x, I'm going from a 6, and I'm going to end up at this x number. Since I divided by 2 up here, I'm going to divide by 2 down here. 6 divided by 2 gives me 3, which means that 3 is the value of x. All right, next question. Let's use this long diagonal side here. Okay, so I'm going from a 5 to a 15. So 5 to 15. And you could think, well, what am I doing to go from 5 to 15? Obviously, it's getting bigger, so here I'm going to be using multiplication. And I need to think, well, 5 times what number gives me 15? 5 times 3 gives me 15. So when I look down here at the bottom sides, I'm going from a 3 to x. Since I multiplied by 3 up here, I'll be multiplying by 3 here. So 3 times 3 gives me 9. All right, next question says a rectangle has a width of 5 and a length of 8. Which answer shows a scale drawing of the rectangle with the scale factor 1/2? Okay, well, anytime I have a scale factor, all I need to do is take that scale factor and multiply it by my side lengths. So here I have a side length of 5. I'm going to multiply that by 1/2. I have another side length of 8. I'm going to multiply that by 1/2. 5 times 1/2 is 2.5. 8 times 1/2 is 4. Again, feel free to type that into our calculator to make sure you're getting those numbers correct, which means that I want to choose a rectangle that has the side lengths of 4 and 2.5. All right, our last question says a scale drawing of triangle ABC has side lengths of 2, 4.8, and 5.2 centimeters. The scale drawing was using a scale of 1 centimeters equals 4 inches. And so then Raquel is going to create a different scale drawing of a triangle ABC with a scale factor of 1 over 16. What are the side lengths in Raquel's scale drawing? This question is a little bit trickier because we need to find the scaled image twice. We need to first use this scale factor here, then we're going to use Raquel's. Okay, so first we're going to find triangle ABC with the 2 centimeters, 4.8, and 5.2, we need to change all of those to inches. Okay, for every 1 centimeter, I get 4 inches. So if I have 2 centimeters, I would have 8 inches. Okay, this scale factor here is essentially telling me I have a scale factor of 4, which means I'm going to be multiplying all 3 sides by 4. Okay, so 2 times 4 gives me 8. I can pull over a calculator to help me with the rest. Okay, if I have 4.8 times 4, and then I'm going to have 5.2 times 4. So that gives me 19.2 and 20.8. Okay, so this is my inches triangle. That was our first scale factor. Now we need to take this and we need to multiply all 3 of these sides by our new scale factor, which is 1 over 16. And when we do that, we will get our new triangle down here. So I'm going to take all 3 of those sides and I'm going to multiply it by 1 over 16 using our calculator. And I'm just going to type all these in. 20.8 times, oops, not divided by, times 1 over 16. And 19.2 times 1 over 16. So I get side lengths 0.5, 1.3, and 1.2. Which means that this is the correct answer. That is how Raquel got those side lengths. So first, we took our triangle with the centimeters, changed it to inches. Then we took that triangle and multiplied it by that 1 over 16 to get to that answer. All right, and that is it for lesson 21. Thank you for watching.